Today, we are going to discuss real-time teaching capabilities of the platform, which is based on provided memories for user application instance. First, as we discussed earlier, short-term inference stack, which is available while fulfilling user request in order to retrieve any collected information during user dialog with an application. Second, we can utilize user instance persistent memory to store user-specific information like names, allergy types, if we are talking about cooking application, for example, and other related data. And third, application-wide persistent memory. Example could be all common allergy types, again for the case of cooking application. All of these types of memory can be used during fulfillment, and I can show you how. Let's review the example from the tutorial repository. Here's the configuration file. There is nothing new here with an exception of definition of error intent. Error intent is defined to tell the system to generate this value when user ended up not having any intent deduced explicitly, which is quite possible when user uses the phrase unrelated to the application knowledge domain. You could also assign the prompt value to f_none, which would be something like I didn't get it or I don't understand. You can add as many variations as you like. Also note we use f prefix for the intent none here to indicate that we don't want to store this inference in the inference stack. In this micro Smalltalk tutorial project, we show name exchange between user and the chatbot and answering users' questions about favorite colors, but we will focus on name exchange. User's name is stored in the instance persistent memory and it is used in fulfillment, so the goal is to make our chatbot as intelligent as possible. Take a look at the user section here, where the user asks what is your name question to the chatbot. Bot will answer the question and also ask user to provide one unless bot already knows it. Also, user can change the name and bot has to handle it, and this is the gate to implement this logic. As you can see, we check the intent for name question, and if username is already available, the dynamically assigned intent will be tell my name, which corresponds to the user prompt in the bot section to the my name is silly, good to see you, and provided username, stored username. If the name is not available, another intent will be assigned tell my name and ask users, which you can see here corresponds to the prompt my name is silly, what is yours? And then user would reply my name is John, for example, as you can see here. The following gate will invoke Python script where username will be stored in the user persistent storage. As you can see, we pass in inference object O with user-specific data as user and available session ID for the user instance. In the definition of username function in the script session, we can see that we double-check the intent username, also verifying whether the username is actually available. Keeping in mind that all parameters are presented as a list, we take the last one. And then we check from user object whether it exists or not and assign to it if it's not, and also save it to user JSON file, converting the dictionary object into the JSON. And this is user persistent storage instance, and we set the share to false. We also check here if name is already known, and we would generate intent I know your name, and we would say to user something I already know that, or something like that. And if it's new name, we would generate username change intent, storing old name into old name and new name assigned into user object, and save it. And also, if we take a look at the username change prompt definition, we would see that the prompt is, oh, you decided to change your name. Okay, here's your old name. From now on, I will call you, and this is a new name. Here is the variables section, where we defined as user object. Before I said it's a dictionary, but it's actually namespace. So this is a definition of user instance Python object, which we use to store username and favorite colors. And if we go to file init Python script, we would see that very first gate that will be fired based on the fact that the init variable will be false in the very beginning. We read the content of user JSON file into this object and converted it into the namespace. Next thing I would like to mention is more of a recommendation than the rule. When you have more or less complex dialogues in place with lots of gates, I would recommend to break training files like this. Have main logic file with a single key utterance with intent and corresponding gate, if any. All paraphrased utterances should go to another file. That includes both section prompts paraphrasing as well. This way you can have well-structured training files and clear visible logic of the conversation. For example, here we have only one utterance corresponding to the intent name queue, name question. What is your name? All other paraphrased utterances would be put to another file. We have this file named main.txt, and all paraphrased utterances will go to main extension. You can call it whatever you want. And here you can see I mentioned error intent. I have definition in the bot section. Sorry, I didn't get it. I did not get it. I'm confused, and maybe others. Paraphrasing name question. What is your name? Your name, please. Your name. What name do you go by? And others. Let's come back to the gate code where we use dynamically assigned intents, so we can define new corresponding user prompts. Is it mandatory? No. You could have just assigned the prompt directly in the gate's code as a string, similar to this assignment, but instead of intent you would have prompt slot name. I will leave it for your consideration if it works better for you. We use this approach to have bot or prompt section isolated for better management if changes are required in the future.